So if I take a look at problem number 1, we want to find the first three terms in the expansion of x minus y to the 14th. We don't want to work Pascal's triangle all the way down to the 14th row. Instead, we can use our combinations, knowing that our coefficients come from starting off by choosing 0 out of n, the exponent. So I'm going to take 14, choose 0. Then I know my a term always starts off with the highest exponent, which in this case would be 14. And my b term starts with the lowest exponent, which would be 0. As I move along, I'm going to continue to now choose 14, choose 1. The exponent comes down by 1 on my first term and up by 1 on my second term. Then my third number in my list is going to be 14, choose 2. The exponent comes down by 1 on my x to 12, up to 2 on my negative y. Also notice a pattern here that the exponent on your b and your combination number will always be the same. Another thing is that my exponents always have to add up to my total. 12 plus 2 is 14, 13 plus 1 is 14, 14 plus 0 is 14. And we're going to use those tricks to help us find different numbers in our list. Once we have our numbers, we can plug these guys into our calculator, do our multiplication, and we get x to the 14th minus 14 x to the 13th y plus 91 x to the 12th y squared. For question number 2, we want to find the 100th term in the expansion of 2x minus y to the 100th. Remember that there's always n plus 1 terms. So if there's 101 terms, that means the last term is the 101st term. Remember that my last term, looking at my Pascal's triangle, always comes from choosing n out of n. So for example, a plus b to the 5th is coming from 5, choose 5. So if I look at question 2, my last term is going to take 100, choose 100. The exponent came all the way down to 0 on my first term and all the way up to 100 on my second term. So then, working one back, I'm going to take 100, choose 99, and then the exponent on my a term would be 1, and the exponent on my b term would be 99. I can multiply this out, and that gives me negative 200 x to the 99. For question number 3, we want to find the term containing x to the 3rd in the expansion of x minus 1 to the 9th. I know that there are 10 terms, and if x is my a term, he's going to start off with the highest exponent of 9 and come down by 1 each time. So once I get to my spot where x to the 3rd is, then I know my b, negative 1, has to be the 6th power because I know my two exponents always have to add up to n. 3 plus 6 is 9. I also can find my combination because my exponent on my second term and however many I'm choosing out of 9 have to be the same. So I can take 9, choose 6, times x to the 3rd times negative 1 to the 6th and get 84 x to the 3rd. For my last one, number 4, if I want to find the 23rd term in the expansion of 2x minus y to the 24th, remember that there are always n plus 1 terms in my list. So if there's 25 numbers in my list, my 25th term is going to have a combination of 24, choose 24. Move back 1, the 24th term would be 24, choose 23. So the 23rd term in the list is going to have 24, choose 22. I know the 22 and the exponent on my b have to match. So my negative y has to be raised to the 22nd, which means my 8th term, 2x, has to be raised to the 2nd because these two have to always add up to my total exponent. So then I can take my 24, choose 22, which is 276. 2 to the 4th, or 2 to the 2nd is 4. Multiply those together and use my exponents, and I get 1,104 x squared y to the 22nd.